So, the distance from a point to a line is the length of the perpendicular segment. Perpendicular segment from the point to the line. This is always the shortest distance between the point and a line. So think of your walk to somewhere. I don't care where you're walking. You're not going to like take the perimeter there. You're going to try to shoot straight for the door, and straight for the door would be 90 degrees. Okay? What? All right. So, if you're given some point, our point is A in this picture, in some line, K, the shortest distance will always be the perpendicular. Because if I went from like A to this, if I called this C, that's a lot farther away than from A to B. So if we're looking for the shortest distance, we always want the perpendicular distance. All right. It says, find the distance from a point to a line. I gotta lock my focus so it doesn't keep moving around. Maybe. All right. Hopefully it stays here. So, it says, find the distance from point A to the line BD. This is A. This is the line BD. Which one's going to be the shortest? To B, C, or D?
B.
From A to C, because that's the perpendicular. So you need to use your distance formula. Hopefully you remember that guy.
Can you write that down?
Because AC is perpendicular to, what do we call it, BD? Who remembers the distance formula?
Me.
Oh, wait.
What is it?
Isn't it like A1, x1 minus x2 squared plus y1 minus y2 squared?
Yep.
You remember that?
Yeah.
So it's the difference in your x's squared plus the difference in your y's squared. It's pretty easy if you break down why it exists. When we do subtraction and we're taking the square root, we always have to square it so that we don't have a negative number. So that's where the squaring comes from. And we're taking the distance between the two, so we have to subtract them. And it doesn't matter if you put x2 or x1 first or y2 or y1 first. You just have to be consistent using the same coordinates for the first one, same coordinate for the second one. All right, so I'm going to leave you B, and you're going to tell me what the distance is between point A and line BD. And tell me what the estimate is. What is the square root of 32?
What I have.
6 squared is 36, so it has to be less than 6.
5.6.
5.6.
Or if you want to find 5.6.
So what's the next decimal?
5.
All right, then I'll just leave like that with 2 decimals. All right, so 5.7 or 5.65, whatever you want to round to.
I did that mentally.
Remember that you have to know the difference between an exact answer and an approximate answer. Which of the two would be your exact answer? The square root of 32. Once you get a decimal out, even if it's a nice decimal, it's still an approximate. So if it says, what is the exact answer, you need to leave it under the square root symbol.
Even if you get like a 5.5.
If you got 5.5, you're good. But if you got like 6 or 7 decimals, then you're approximating. All right. So what do we know about a perpendicular bisector? What does the word perpendicular mean? If they meet at 90 degrees. So if we're using this picture, we would know that N is perpendicular, which is the upside down T, to the line PQ. Okay, what does bisector mean?
They meet, crosses the middle.
The middle, and it makes what? All right. So bisector means it splits it in half and gives us 2 equal parts, which would mean that N is going to pass through the midpoint of PQ. So I'm going to say line N passes through PQ at the midpoint. which gave us those two equal pairs, so that we know PM is the same as QM, which is going to be a very helpful thought later on. So remember, if you're told you have a perpendicular bisector, you know it splits the other line into two pieces, and it meets at 90 degrees. Those are the two key factors. All right, once you have that, flip your page. And these are like the only theorem-like things we can get from parallel or perpendicular lines. The linear pair perpendicular theorem says, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Basically, so if you're told two angles are 90, you know the lines are perpendicular, right? All right. The next one is the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one. Why does that make sense? If we know it's perpendicular to the first one and the two lines are parallel, how do we know it's perpendicular to the next one?
Because they're the same. The lines are parallel.
Because the two lines are parallel, so it's going to intersect at the same degrees. Because they have the same slope. Remember that? Because that's what our next section is.
It's over.
Looking at parallel and perpendicular slopes.
It's over.
Whoop, whoop.
At least we're doing real math.
All right, and the last theorem there says, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, they're parallel to each other. Why is that? Because if these two angles are the same, technically we have corresponding angles. Right? And if they're the same, that would be the corresponding angles converse, proving the two lines are parallel. So it's not really its own theorem. These are just built off other ideas. All right, so let's try a proof, because we love them.
Oh.
Proving the perpendicular transversal theorem. We are given that H is parallel to K and that J is perpendicular to H. What do we know? What should be our first statement? H, what?
It should be the given.
It should be the given. So H is parallel to K and J is perpendicular to H. And our reason is that it's given. Okay? Then it says the measure of angle 2 is 90 degrees. How would we know that?
Because they told us.
Because we're just smart.
Because they're perpendicular? Do I need
Yeah, the definition of perpendicular lines, right? If they're perpendicular, they meet at 90. So definition, I just write DEF for definition.
Definitely.
Definition of perpendicular lines. Oops, I forgot my R. Perp lines. All right. You know, it's frozen. Then we said prove that J is also perpendicular to K. And we're going to use this picture on the right here. So we already figured out that the reason angle 2 is 90 is because we were told we have perpendicular lines. And this is an R because I can't spell today. So what would be our statement for number 3 if we're using the corresponding angles as our reason? So we know we have to do something with angle 2 because that's the only thing we've talked about so far.
Isn't angle 2 is equal to angle 6?
Angle 2 should be equal to angle 6 because those are corresponding angles. Okay? So what would our reason be then for number 4? So it says this, or yeah, our statement. What's our statement if we said this is the definition of congruent angles?
Congruent means you should definitely remind me of the definition of congruent.
Congruent just means equal and the same orientation.
Around so much when we're doing like.
Do I need this to be a mechanical engineer?
What do you mean?
Like we literally like just learned like so much like this, and now we're on the unit.
That's why we're in geometry. We're supposed to.
It's
You're the one that asked.
So if we're trying to talk about why two angles are congruent, we're talking about their angle measures. So we would say the measure of angle 2 is congruent to the measure of angle 6. Try to zoom in since I made it smaller up there. Okay. So then why is the measure of angle 6 90 degrees?
Because it's congruent to the measure of angle 2.
What's the reason?
Because they're perpendicular.
Isn't it the same like congruent?
We're looking for a property of equality. What property of equality would this be?
Wow, I'm pretty sure we have said every single one except for one. Congruent.
Yes?
The definition of congruent? No, we just did that. Transitive code?
Transitive! I knew there it is!
It's on the tip of my tongue.
The transitive property of equality. We said angle 2 was 90. If angle 2 equals angle 6, then angle 6 also better be 90 because of the transitive property.
I literally just sat there and thought about what's the most random one.
Alright, so what then is our reason for our last statement?
Because is there another
H is parallel. K is parallel to H.
Okay, the paper balls need to go in the garbage before I lose my marbles.
I made it.
Stop throwing it, I said.
I threw it.
What's our reason?
You threw it.
That was straightforward.
If two lines are meeting at 90 degrees, what do we have? So the definition of perpendicular
The
lines.
line. Definition, where you got it. Nope. Nope.
Definition of perpendicular lines.
Depth of curved lines.
All right. We've got one last example to do together on the last page here.
Just why?
You're given a map. So I'm going to zoom in on mine. All right. So we've got the map of a city here. And we know that some of the lines have names. You need to figure out which, if any, are parallel and give a reason.
ST and O.
I'm going to pause it.
S&T.
All right.
This makes zero sense. This isn't even math.
You got it.
So we are trying to see if we can prove any of the lines are parallel. We can see some of them are perpendicular because we can see the little right angles. We've got the little right angle here and the little right angle here.
Yeah.
So what do we know?
Yes.
Some lines are perpendicular, some aren't.
Okay, which ones are perpendicular?
Yes.
The ones that the perpendicular to the S, T.
So
All of them
Q and T
are
and
perpendicular
Q and
to
S.
something. They're all perpendicular.
Yeah.
well, we know that S and T are perpendicular. I'm going to write down what our thoughts are. S and T are both perpendicular to Q.
Yeah, who doesn't have that thing?
Yeah.
And then you use the
Okay.
what's it?
Two of these.
Lines
Wrong,
to
guys.
perpendicular. Lines
That's okay.
perpendicular to a transversal theorem, which says that S and T.
Interesting. So the theorem we talked about on the last page that says if two lines are both perpendicular to the same line,
They're parallel.
then they're parallel. So we're going to say
How am I supposed to remember that?
by the lines perpendicular to a transversal theorem. So by the lines perpendicular to a transversal theorem, which two lines are parallel? S and T. That's it. That's it, right? Yes. All right.